Hey guys, and welcome to our video on naming organic compounds. So today in this video we'll be giving you a brief overview on just naming organic compounds in general. I recommend you supplement this video by looking over our video on functional groups as well as doing the multiple choice questions and the flashcards associated. So like with all things in chemistry, it's important to actually understand what you're doing before you start doing it. So you might be thinking, why do we actually need a naming system in the first place? Firstly, that's because functional groups, double bonds, and triple bonds can assume different positions on the carbon chain. So for example, if I would have a 3-carbon molecule here, a functional group X on this carbon would be a completely different molecule to the functional group on this carbon. So thus we kind of need a naming system to differentiate between these differences. Another couple of points that you need to know. So we name everything with respect to the longest carbon chain, and that's a theme that's going to be carried out throughout the whole video. So finding the longest carbon chain first. Next, we number the functional groups as they're present on the largest carbon chain. So again, you find the longest carbon chain, you look at the functional groups that are attached to that longest carbon chain, you number them accordingly. A big thing, if you're ever stuck in an exam, give it a go to the best of your ability. So find the longest carbon chain, find the functional groups, and when you're naming, examiners are quite pedantic. So you need to remember that dashes belong between letters and numbers. So this is a dash, and commas between numbers and numbers. And we're going to go through some examples later, and it'll become more apparent as to what that means. So I've talked a fair bit about the longest carbon chain, but what does that actually mean on paper? So I want to introduce you to 3 compounds here, and whilst they might look different on paper, they're actually exactly the same compound, just arranged in different manners. And that's a trick that examiners will continuously use. So I'll run you through it. So if you look at this first compound to the left here, it has a carbon chain of 1, 2, 3, 4. As does this, 1, 2, 3, 4. And as does this, 1, 2, 3, and 4. So the first thing I want you to do when you're naming organic compounds is look for one continuous line of carbon molecules. And once you've found that longest line, that is your longest carbon chain. So for example, if I were to break this single bond up here, this compound then has a longest line of 2 carbons. So it's no longer a 4-carbon chain, it's now got 2 lots of 2 carbons, if that makes sense. So yeah, before you start naming anything, look for the longest continuous line or snake perhaps, and then go from there. So once you've got the longest carbon chain, so for example, we're going to work through each of these molecules. So starting on the left, the longest carbon chain, so 1, 2, 3, 4, 5. And if you remember on the videos in the functional groups, a carbon chain with 5 carbons is a pent. We use a suffix of pent. The next thing you're going to do is look for functional groups. So here we have a fluorine attached, and please refer to our video on functional groups if you need a refresher. So we're not going to build onto it too much because we'll build on this concept in the next slides. But what I want you to take from this is the process. So I've identified the 5-carbon chain, and I've identified that this has a fluorine functional group attached to it. And as you know, we're going to use the suffix pent, and this thing has the suffix, or prefix rather, fluoro, as it's a halogen. I'll bring your attention to the second molecule. So this is a carbon skeleton, but same process really. So recall from the previous video that every kink in the carbon chain is 1 carbon. So again, the first thing we're going to do is find the longest carbon chain, always. 1, 2, 3, 4, 5, 6. So 6 carbons, which is hex, and it's got a double bond O, which means that this is a ketone. So this would have the suffix anone. That's all I want you to take from now. We're going to build on this in later slides. Thirdly, we have 1, 2, 3, 4, 5. So the prefix pent, and then it's got the OH group. So that's going to have the ol, because clearly this is an alcohol. So in this way, if you remember this process, you can pretty much name any organic compound. And that's something, we'll give you a couple of tricks to work on in the next couple of slides. But just remember, the first thing you want to do is look for the longest carbon chain. So look for that longest line, and then start to look for functional groups. So you may recall from the first slide that I mentioned one of 2 things. So the first thing I said that was on the carbon chain, the functional group can assume any position on that carbon chain. So for example, if we have the fluorine attached here, it could be on any of these carbon chains, right? Could be here, so on and so forth, right? And each of these would have different properties, and they'd just be different compounds altogether. So we kind of need a naming system or a numbering system that helps us differentiate between these different compounds. In class, you might hear IUPAC or IUPAC thrown around. That's essentially just the governing body that came up with this naming practice. So everyone's on the same page. So if I say 2-fluoropentane, everyone in the world knows what I'm talking about. So in the previous slide, I introduced you to 3 different compounds, and now I'm actually going to step it up a notch, and we're actually going to work through numbering them. The most important thing when it comes to numbering is remembering you want to give each functional group the lowest possible number. So to not complicate things, we're going to look at just carbon compounds with one functional group first, and then in later slides we'll improve upon that. So starting with the first compound, the first thing we have is 1, 2, 3, 4, 5 carbons, and we can name them like this. However, this is just a 2D representation of a 3D molecule. So what's to say that this carbon here can't also be carbon number 1? And then this 2, this 3, this 4, this 5. So one thing I want you to remember is when you transfer a 3D kind of molecule into a 2D shape, you lose that sense of perspective. So there's no like single way that you can number. So you can number from 1 to 5 left to right, or 1 to 5 from right to left. You just need to number all of them. However, you need to pick a direction in which it gives the functional group the lowest possible number. And what do I actually mean by this? I'll show you. So if we look at from left to right, so left to right, so left being 1, right being 5. The fluorine is on the second carbon, so 1, 2, right? However, if we go the other way, so from right, to left, so this being 1, 2, 3, 4, 5, the fluorine is now carbon number 4. And that is not the lowest possible number we can give. So thus, the correct way to number it is from left to right, 1, 2, 3, 4, and 5, because that gives it 2. Although essentially it's on the same carbon, just for simplicity's sake, we give it the lowest possible number. Now we're going to combine everything together. So we know it's on carbon number 2, and if you recall from the first slide, I said commas between numbers and numbers, dashes between numbers and letters or numbers and words. Same thing really. That's a really important thing to remember. So 2 is where the functional group is. The dash, because it's a number and a word. The fluoro indicates the functional group, and this is a pentane. And that's basically how we number it. So you go count the longest carbon chain, so 1, 2, 3, 4, 5. Look for functional group, so it's got a fluoro. Give it a number in regards to the lowest possible number you can give. So go from right to left first. If that doesn't work, try left to right and see which gives you the lowest number. In this case, left to right works. So numbering the left carbon 1 and the right carbon 5. It's in the second position. So it's a 2-fluoropentane. And we can kind of use this principle for all molecules. So we're going to work through the next one. So we'll look for the longest carbon chain first. So 1, 2, 3, 4, 5 carbons long. So I know this is going to be a pent something, right? Now we have a functional group of an OH. And you may recall from our previous videos, OHs are alcohols, so they have the suffix -ol. Now we need to number this thing. So we're going to try from left to right first. So 1, 2, 3, 4, 5. And also when I say from left to right, I mean naming or numbering numbering the carbon on the left-hand side, 1, and then going across. So in this way, we get the OH on the 4th carbon. So let's try from right to left. 1, 2, 3, 4, 5. Much better. So it's now in the second position. And this also kind of makes sense. So this is a little conceptual, but if you think of this thing as like a 3D shape and you rotate it around, it would kind of just look like, it would look like this thing, just with an OH, right? If that's too much for you, fair enough, I understand. But just remember, give it the lowest possible number. So we currently have a carbon chain of 5. The second carbon holds the OH group. So it's a 2-pent, and then the ol suffix, because of the alcohol. So whilst this kind of works, it relies on you to know your functional groups well. So I recommend doing flashcards or multiple choice questions to revise those. The last one. So this one, first things first, I'm looking for the longest carbon chain. So 1, 2, 3, 4, 5, 6. So this is a hex. So now I'm looking for functional groups. So I have a double bond oxygen, not attached to any hydrogens, just carbon chains on either side. This is one carbon chain. This is another carbon chain. So this means that this thing is a ketone. And thus, they need the suffix A-N-O-N-E. So this is a hex, and then has the suffix A-N-O-N-E. It's also kind of hard to give you like a formula of, okay, put the number here, put the dash here, because, so for example, the fluoro, the functional group, is a prefix, whereas the hydroxyl has a suffix OL. But if you carry the concept of first looking for the longest carbon chain, so in this case a hex, and then looking for functional groups, and then memorizing the prefixes and suffixes for each of the functional groups, you'll pretty much be fine. So 1, 2, 3, 4, 5, 6. So we're gonna need to number this thing. So we can also number it backwards. So 1, 2, 3, 4, 5, 6. So clearly this is on the 4th position, and doing it from this way gives us the 3rd position. So that's the one we're going to go with, as it's the smallest number. So we have some information. So we have a carbon chain of 6 carbons long. We have a ketone, which is in the 3rd group. So now we're going to combine all these things first. The first thing you do is put the position of the functional group with the number. And then always remember, dashes between numbers and letters, or numbers and words, commas between numbers and numbers. So number, then put a dash, then this is a hexane. However, it's got the ketone group attached, which gives it the suffix anone, because it's not just a normal alkane, it's now a ketone because of that functional group. However, it's got 6 carbons, so it's a hexanone, and this is 3-hexanone. So we're going to build upon this again, and now we're going to start fully naming compounds. So I want you to combine the knowledge you learned in regards to looking for the longest carbon chain, looking for functional groups, and then numbering them. And this is what we're going to do now. So starting on the left, the first thing we're going to do is look for the longest carbon chain, and that is this one here. So the first thing I need to gather is how long is that chain. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So, and you may recall from the first video that gives us the prefix non. The next thing we're going to do is look for the presence of any functional groups. So I have this iodine molecule attached here. So that's going to give us the prefix iodo. The next thing we're going to do is number this functional group. So starting from left to right, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is in the 4th position. Now we'll try the other way. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's in the 6th position. So we're going to take the lowest number, so it's in the 4th position. Now we're going to combine it all together. So it's 4-iodo, signifying the functional group and where it's at. And always remember, dashes between numbers and words or letters. And then non, signifying the length of the chain. And this is an alkane, so it's a non-ane. So this is 4-iodo non-ane. We're going to keep going. So on the second compound, same principle. So the first thing we're going to do is look for the longest carbon chain. So 1, 2, 3, 4, 5, 6, 7. This is the prefix hept. We're going to look for functional groups. So this is the OH group. So this is an alcohol, the prefix ol, suffix, sorry. Now we're going to name it. So I can see it's closer to one side, so it's probably going to be best if we number it this way. Initially, I recommend you get in the habit of numbering both ways, but as you do more of these, you'll just realize that, yeah, one side is preferred to the other. So this is in the second position. So this is 2 hept ol. Now look at the difference between these. So the first one, we had the functional group took a prefix, and the second one, the functional group took a suffix. But the general consensus of where the functional group is, the dash, and the length of carbon chain kind of stays equivalent in both. It's just the functional groups that change. So the last one here. Again, longest carbon chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's dodec. We have the bromine group, which is in the 1, 2, 3, 4th position. So this is 4 bromo dodecane. Usually won't get a carbon chain that long, but it's best to just know them. So hopefully you have a pretty good understanding now of how to just name some simple carbon compounds. And in the next couple of slides, we're going to go over some common tricks examiners like to use to catch you out. So firstly, what do you do when, say, there are more than 1 or 2 or more functional groups attached to the carbon chain? There are 2 important things you need to remember. Number 1, you arrange the functional groups when you're naming them in alphabetical order. So we're going to go over this in the next slide, but here I want you to focus your attention on this compound here. We have a fluoro and an iodo group attached to the carbon chain. Like in the previous example, when we're naming it, we go number dash prefix of the functional group. However, we have 2 this time. We're going to do the same thing. However, we're going to arrange them in alphabetical order. So F comes in the alphabet before I. So the fluoro goes first, dash, and then the iodo. And we're going to go over that in the next slide, so don't stress. The next thing is your numbering system. So right now, we learned that you give it the smallest possible number, which is true, and that actually holds true when you have more than 1 functional group. So you need to number it in a direction, so from left to right or right to left, such that the total number, so the addition of both the functional groups' numbers, gives you the smallest number possible. And hopefully that'll become a lot more clear in the next slide. So hopefully that's a bit more clear. And now we're going to go over the names and try and reverse engineer the names from the previous slide. So starting on the left, always the first thing we're doing is looking for the longest carbon chain. And in this case, it's 1, 2, 3, 4, 5 carbons long. Next, we're looking for functional groups. We have 2 in this case. We have the fluoro and the iodo functional groups attached on either end of the carbon chain. Next, we need to number these functional groups. So starting from left to right, 1, 2, 3, 4, 5. And that works. So in this case, it doesn't really matter because they're on either ends. So we'll just stick to this. Like before, the naming system still stays continuous. So it's number dash the functional group or the prefix. However, this time, since you have a second one, you're adding another dash in between. And always remember, dashes between letters or words and numbers, commas between numbers and numbers. So in this way, you have 1 dash fluoro. So think of it like blocks. Dash 5/iodo. Pentane, because it's a 5 carbon long chain. In the next example, we have a 1, 2, 3. So this is a pro. And then we have a amine group attached. So this is a propanamine. However, we're not done yet. We have another functional group attached. So this is the chlorofunctional group. And now we need to number it. So 1, 2, 3. And even if we go from this direction, it's still in the second position regardless. So this is 2 chloropropanamine. Now look at the difference between this and this. So when you have functional groups that are both prefixes, so fluoro and iodo are both prefixes. However, this amine is a suffix of the name. So this naming convention in which you give the you kind of stack the prefixes. Only kind of comes into effect if you have two functional group, both of which you name by the prefixes. If you have one with a prefix and one with a suffix, you can just combine them like this. So 2-chloropropanoamine. We'll carry on. So kind of in a similar vein in the third compound. So we have 1, 2, 3, 4, 5. So this is a pent. And it's got an OH group on the end. So this is a pentanol. Now we need to number the functional group. So 1, 2, 3, 4, 5. However, this isn't advantageous. So numbering it this way doesn't really work, because if we were to give this the 5, so this would be 5-pentanol. However, we have another functional group. So this is the chloro in the third position, right? So it'd be 3-chloro, 5-pentanol. And that's a pretty high number. However, if we name it the other way, so make this 1, 2, 3, 4, 5, this is 1-pentanol, and this is 3-chloro. So recall before how we had 3 and 5, that gives us a total of 8. Here we have 3 and 1, which gives us a total of 4. So in this way, you're kind of minimizing. So instead of before, when you had one functional group where you're minimizing just the maximum number, here you're minimizing the maximum total. And by total, I literally mean you're adding up the numbers in the functional groups. So naming it from right to left, or numbering it rather from right to left, gives you the lowest combined kind of score, really. You're kind of trying to minimize the score. So in this way, you go 1, 2, 3, 4, 5. Chloro is in the third position. The alcohol group is in the first position. You can write 3-chloro, 1-pentanol. However, since it's in the first position, you can just write 3-chloropentanol. Now we have a little more of an interesting one. The same thing really applies. So I'm going to go skip straight to ahead. So 1, 2, 3, 4, 5 carbon chain. So this is a pent. It's got the alcohol group, so it's a pentanol. Now we're going to need to number it. We have two functional groups. So if I name it from right to left, so 1, 2, 3, 4, 5. The fluoro is in the 1 position. The chloro is in the third position, and the pentanol is in the 5th position. Let's try and name it the other way, the number rather the other way around. So 1, 2, 3, 4, 5. So the alcohol is in the 1 position. The chloro is still in the 3rd position, and the fluoro is in the 5th position. So for this one, it doesn't really matter how you number it. So to save us a bit of trouble, we're just going to go from left to right. And this is 3-chloro, 1-fluoro, pentanol. So that's probably the hardest example you get. So to combine the kind of stacking the prefixes with the suffix. So the first part is the chloro, because C comes before F in the alphabet. So chloro first, and then the fluoro, and then the pentanol. So your main takeaways from this should be, okay, so now you know firstly to look for the longest carbon chain. Secondly, you're looking for functional groups. Thirdly, you're picking a direction in which you want to number. So from left to right or right to left. If there's one functional group, you want to number it in a direction that gives it the lowest possible number. If there's more than one, you're numbering it in a direction that minimizes the total number. So it keeps the total number as small as possible. The third thing you need to do is naming it in alphabetical order, and that's the most important thing. So if I were to swap these around and call this 1-fluoro, 3-chloro, pentanol, it'd be wrong. So it'd be 3-chloro, 1-fluoro, pentanol. And when I say alphabetical order, organizing the functional groups in alphabetical order is the most important thing. So now we're going to step it up another level. And what do we do in cases in which we have more than one functional group, but they're of the same kind? So for example, in the first compound, we have 2 chloro groups, or in the second compound, we have 3 fluoro groups. What do we do in that case? Well, the same convention follows. However, you assign a di, tri, tetra, pent, so on and so forth to the functional group. So this would be a dichloro compound. This would be a trifluoro compound. And in the next slide, we're going to look at the names and try and reverse engineer why that's the case. So here are the names of the compounds in the previous slide, and now we're going to try and reverse engineer why each one relates to the name. So starting on the left, first things first, longest carbon chain. So 1, 2, 3, 4, 5, 6, 7. So this is a heptane. Next, we're going to look for functional groups, and we have 2 chloro groups here. Next, we need to number the functional groups. So going from left to right first, so 1, 2, 3, 4, 5, 6, 7, and from right to left, 1, 2, 3, 4, 5, 6, 7. So from left to right, we have the 2nd and the 5th position. So this gives us a total of 7. From right to left, we have the 3rd and the 6th position, which gives us a 9. So 7 is clearly the smallest, so we are going to go from left to right. So, number from left to right. The chloro is in the 2nd and the 5th position. Now, what do we do since there's 2? Like I said, as I've been saying, commas between numbers and numbers, dashes between numbers and letters. So the first thing you need to remember is you use the prefixes di, tri, tetra, pent, so on and so forth. So they're a bit different from the alkanes, so meth, eth, pro, bu. It's a bit different to that. So these are a lot more intuitive. So di, two, tri, tetra, so on and so forth. So if there's 2 of the same functional groups, you would assign the prefix di. In this way, we can name this thing. So there's a chloro in 2nd position. There's a chloro in the 5th position. So we could write 2-chloro-5-chloro heptane. But to save space and time, we just say 2,5-dichloro heptane. And that relates to that here. Same thing for the second compound. So the first thing you're going to look for is the longest carbon chain. So 1, 2, 3, 4, 5, 6, 7, 8. We're going to number it. So 1, 2, 3, 4, 5, 6, 7, 8. So it's in the 2nd. So I'm going to number it from the other side as well. 1, 2, 3, 4, 5, 6, 7, 8. So from left to right, it's in the 2nd, 7, and 8th position, which gives us a total of 17. From right to left, we have 1, 2, and 7, which gives us a total of 10. So in this way, we're going to number it from right to left. So we have 3 fluoro groups, 1, 2, and 7th position. Again, we could write 1-fluoro, -2-fluoro, -7 -fluoro octane. However, we just go 1, 2, 7 -trifluoro octane. Now, so far we've been dealing with functional groups that have prefixes in the name, so fluoro, chloro, bromo, iodo, so on and so forth. What if we have functional groups, 2 or more of which have suffixes in the name? How do we name those? So same concept really. Again, longest functional group, longest carbon chain, 1, 2, 3, 4, 5. So this is a pent of some sort, right? It's got 2 alcohol groups, right? Now we need to number it 1, 2, 3, 4, 5. And if you go the other way, 1, 2, 3, 4, 5. In this case, it's in the 3rd and 2nd position. So this gives us a total of 5. And in this case, it's in the 4th and 3rd position, which gives us a 7. This is an important lesson. Don't always assume you can number from left to right. Make sure you try both and get the smallest number, right? So we have the hydroxy group in the 2nd and the 3rd position, right? Numbering from left to right. So how do we name this? Same thing, 2, 3 dash. However, we don't write dihydroxy. We write pentane diol. So instead of pentanol, it's pentane diol. And if there were 3 hydroxys, you'd go number it. So 2, 3, and it might be in the 4th place, 2, 3, 4, and then it'd be pentane triol, and so on and so forth, right? Last one. So this one's a little different. It's a bit of a trick. I've thrown it in here just to test your understanding. So we have 2 of the same functional groups, and then we have one that's completely different. So now we need to combine all of our understanding so far, right? However, if you follow a system, you can get all of these right. So first things first, we're looking for the longest carbon chain. So 1, 2, 3, 4, 5, 6, 7, 8. So this is an octane of some kind, right? Next, we need to number 1, 2, 3, 4, 5, 6, 7, 8. Going from right to left, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to start at the bottom. So the functional groups are in the 4th, 6th, and 7th. And this will give me a total of 70. However, from left to right, they're in the 2nd, they're in the 3rd, and they're in the 5th. So this gives me 10, which is a lot smaller than 17, right? So numbering from left to right. Now I'm going to look at the functional groups I have. So I have 2 fluoros and 1 iodo, okay? So I've got the numbering, I've got the fact that it's an octane. I know I have 2 fluoro, so it'd be a difluoro, and I have a 1 iodo. And always make sure, if you haven't noticed already, we never write a mono. So there's no mono iodo, nothing like that, right? Or mono-ols, nothing like that. It's only when you have 2 or more of the same functional groups that you worry about using the di, tetra, penta, and so on and so forth. So now, since I have 2 or more functional groups, remember alphabetical order. F comes before I, right? So now I'm going to combine everything. So the first thing I name is the fluorine groups, right? Because it comes before the I. So it's 2, 3 difluoro dash. So this is a letter or a word and a number. Dash 5 dash iodo and then octane. Admittedly, this is a harder example, but my belief is if you follow this systematic approach, you can name anything pretty much. This is just a short slide giving you the brief overview of the systematic approach I was just talking about. So up until now, our discussion in regards to naming organic compounds has strictly been on alkanes. However, now I'm going to introduce you to the concept of naming alkenes and alkynes. A way or like a frame of mind that I like to be in when naming alkenes and alkynes is that I like to treat them as a functional group, right? So the map that I was talking about before. So finding the longest carbon chain, looking for functional groups, and then numbering them, giving the functional group the lowest possible number. That still applies with alkenes and alkynes. However, in this case, the functional group, quote unquote, is the double or the triple bond, if that makes sense. Here I have 4 compounds. We're going to go over them in the next slide and kind of reverse engineer the names of each of them. There's a reason I've actually included specifically these 4 rather, because I wanted you to get good practice on just a simple organic compound with a double bond. Then it's important you know how to name those with more than 1 double bond, and then what to do when it has, say, a triple bond and a double bond at the same time. So here are the names of the 4 compounds that I just stated, and now we're going to go over each of them in a bit more detail. So starting on the left-hand side, the first thing we're going to do is, like I said all the time, look for the longest carbon chain. In this case, it's 1, 2, 3, 4, 5, 6 carbons long, right? So this is a hex something, right? We can see a double bond, and we can treat this as kind of like a functional group, right? However, we run into a problem. Usually a functional group is just like a stalk on the end of a carbon, right? However, in this case, it's actually between 2 carbons. So how do we number it? Well, I'll show you. First, we're going to number as we would, and then from right to left. So you designate the double bond at the first possible carbon. So at the 2nd or the 4th carbon. So not at the 3rd or 5th, right? At the 2nd or the 4th. From left to right, it's between the 2nd and 3rd carbon, and between right to left, it's between the 4th and 5th carbon. So thus, since 2 and 3 or 2 is smaller than 4, we go from left to right. So thus, the double bond is in the 2nd position. Now, with naming this, it becomes a little more interesting because there's no one set naming convention. So you know how before we said number, dash, functional group, and then the rest of the name? Here you can kind of do both, right? So either hex2ene or 2-hexene are both acceptable, whichever one you prefer, right? And how do we actually get hexene? So recall that this is an alkene, and alkenes have the suffix ene, right? And this is a 6-membered alkene, so this is a hexene. It's in the 2nd position, so this is a 2-hexene, or we can also write it as hex-2ene. Always remember, you should never have a space between anything. It should always be a dash or a comma in between. Dashes go between letters or words and numbers, commas go between numbers and numbers, right? And I guess the only reason why you'd need a comma is if you had more than one of the functional groups. So in the previous slides, we went through like the di, tri, and tetra. That's where the commas would come in, and also in the next compound as well. Again, same thing. We're going to go over the longest carbon chain first. We're not even going to look at the functional group. So 1, 2, 3, 4, 5, 6. Another 6-membered ring. So it's a hex something, right? We're looking at functional groups. We have 2 alkenes. Okay, so sorry, 2 double bonds. Now we need to number them. 1, 2, 3, 4, 5, 6. And if we go from right to left, 1, 2, 3, 4, 5, 6. Like I said, you assign the first possible number. So it's on the second and the fourth carbon going from left to right, and it's on the third and the fourth carbon going from right to left. These add up to give you a total of 7. These add up to give you a total of 6. 6 is lower than 7, so we go from left to right. Simple. How do we name it? Kind of works in the same principle as before. So the naming convention kind of sticks. So recall in the previous slide we said that if you had one or more of the same functional group, sorry, 2 or more rather of the same functional group, you'd use the di, tri, tetra, pen, so on and so forth. Same applies here. We have two lots of double bonds. So it would be a diene. So di and then ene, signifying the alkene part. Again, since it's in the second and the fourth space, we go 2, 4 hexadiene. If it had 3 carbons, 3 double bonds, it would be a hexatriene, and so on and so forth, right? Now, we're going to skip over the third compound and go straight to the fourth, because I want to reinforce this kind of multiple bond notion. Again, we're going to go over the longest carbon chain first. So this is 1, 2, 3, 4, 5. It's a little bit complex with the skeleton diagrams and when you have the triple bond, but just remember each kink in the carbon chain is each kink in the skeleton, is 1 carbon. So there's a kink here, there's a kink here, so every corner rather, is a carbon. And there's 5 corners, so this is a 5-membered ring. So it's a pent something, right? This is an alkyne because it's actually got 2 triple bonds, right? Same naming convention applies. So this is a pent something, okay. Now we need to name it. So 1, 2, 3, 4, 5, and going from right to left, 1, 2, 3, 4, 5. Like I said, when naming alkenes and alkynes, you're giving it to the first possible carbon. So it's in the first and fourth position, or the first and fourth position. So it doesn't matter which way you name it, right? Because it's symmetrical. Number it, because it's symmetrical. Either way, it's going to be a 1, 4 dash pentadiene, right? Because it's an alkyne, and they have the suffix "-ine". Now, the third compound is probably one of the hardest that you'll get, right? So this is combining everything really, and that's kind of where this naming system shows its benefits, right? So instead of going 2-hexene, hex 2-ene, right? And I'll explain why. So again, the first thing we're going to do is look for the longest carbon chain. So 1, 2, 3, 4, 5, 6, 7, 8. So this is an oct something, right? We're not going to worry about what it is just yet. It's an oct something. We're going to look for functional groups. So we've got a triple bond and a double bond, okay? So triple bond, double bond. Now we need to number it. Going from right to left, 1, 2, 3, 4, 5, 6, 7, 8. Going from right to left, 4, 5, 6, 7, 8. So going from left to right first, it's in the second and the 5th position, and then going from right to left, it's in the 3rd and the 6th position. 2 and 5 give me 7, 3 and 6 give me 9. And clearly I'm going to pick 7 over 9, so thus I'm going to number from left to right. So, how do I name it? Since there's more than one functional group, I name it in alphabetical order. So right now I have an ene and I have an ine. This comes after E in the alphabet, right? So I name the ene part first. So it's a 3-octen-2-ine. It's a little bit of a mouthful to say, even harder to name. But just bear in mind that if you have a triple bond and a double bond, that is how you'd name it. And then, for example, if you had it in different spots, you just change these numbers around. However, this rule of naming the alkene before the alkyne applies because of the alphabetical order nature, right? So now you should have a pretty good understanding of naming most of the major compounds in your senior studies. There's actually just a special rule when it comes to carboxylic acids and aldehydes, rather. Since these organic compounds or functional groups have a carbon in their actual functional group. So recall that this is the carboxyl functional group, and this is the aldehyde functional group, right? So they've actually got a carbon in the functional group. So how does that work when we're numbering it? Well, automatically, these are carbon number 1. So whenever, this only applies for aldehydes and carboxyls, but whenever you see a carboxyl or an aldehyde on the end of a compound, it is immediately carbon number 1. So you don't have to sit there and number it from left to right, 1, 2, 3, 4, 5, 6. You can just assume that the carboxyl or the aldehyde carbon is carbon number 1. And these are the names as per the naming convention. Okay, so far, as you can see, we have a little process going on. So the first thing we do is find the longest carbon chain, right? And so far that's actually been quite easy. So it's just been a single row of carbons and we can just count them quickly. However, what do we do if there's not just a single continuous line of carbons, right? So for example, I'll bring your attention to the molecule in the middle here. So if we number it like this, so 1, 2, 3, 4, 5, 6, 7, 8, 9, there's a carbon just dangling off there. Or for example, for this one here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's two lots of carbons dangling off. So how do we name compounds like these with an incomplete or branched structure? And over the next couple of slides, we're going to be going over how to do it. So for these branched compounds, the crux of the rule of finding the longest carbon chain still actually applies. So in all cases, you're still looking for the longest possible carbon chain that you can. However, when you're naming these branches, you treat them like functional groups, right? Now, if this branch has a single carbon, as per the previous example, so this one here has just a single carbon, we call it a methyl group. If it's got 2, we call it an ethyl, propyl, butyl, and so on and so forth. And it kind of follows the same naming pattern as your alkanes, so naming alkanes of different carbon lengths. However, you just add the YL at the end. So methyl, ethyl, propyl, butyl, so on and so forth, right? And what do I mean when I say treat it as a functional group? So far, our discussion has been find the longest carbon chain, look for functional groups, number it accordingly, and then name it, right? Nothing changes here. You're still looking for the longest possible carbon chain that you can. Each of these side branches in the main compound, you name in accordance to these, and you number in accordance to what we've discussed previously. And I'll show you the examples in the next slide. So we'll get stuck in with the compound on the left-hand side. First things first, as I said, we're going to find the longest carbon chain. In this case, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons long. So recall that the carbon chain doesn't have to just be a straight line of carbons. It can be a bit windy, but it just has to be continuous. And this is the longest continuous carbon chain, right? So it's got 9 carbons in the main chain. However, we have this functional group branching off to the side. Now, we use the same procedure as we've done before. Okay, we need to number it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. I can already tell that this will give me a larger number because in going from right to left, I only got 4. So since 4 is the smallest number I can get, this is a methyl group because it's a branch of the main chain and it's 1 carbon long. So there's just a single C, right? So this is a methyl group. It's in the 4th position. So this is 4-methyl nonane. And in this way, you can see that we kind of name it in the same manner that we would just a normal functional group, right? The trick with these branched compounds is finding the longest carbon chain. So I recommend you exhaust all your options before you give up, right? So try and find a longer and longer carbon chain each time. And that's what we're going to do for the next one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Or I can also go this way. So this is also a chain. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it doesn't matter. So either way, the longest carbon chain is 9 carbons long. All that matters is where the functional group is. So I'm going to go this way first. So 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. The functional group, the methyl group rather, is on the second carbon. If I go the other way, so 1, 2, 3, 4, 5, 6, 7, 8, 9, the methyl group is also on the second carbon. So it doesn't really matter. Either way, it's going to give me the same compound. So let's name it. So this is a nonane because it's all single bonds. It's got 9 carbons in the main chain. It's got a methyl group, which is a branch. So it's a methyl and it's in the second position. So it's a 2-methyl nonane. The third example is a little more complex and I'll show you why. So we need to find the longest possible carbon chain, right? So we can go this way first, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10 so far. I can also go maybe this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Or I could try this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this is the branch here. So I've exhausted all my options, and now I know that the longest carbon chain is 10 carbons long. So I know it's a dec something, right? It's got a suffix of dec. Now I need to name the functional groups, okay? If I go like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's a methyl group and another methyl group. So it's in the second and the third position. So this is a 2,3 dimethyl decane because it's a 10 carbon long chain. And notice how that naming convention follows what we discussed before. So whenever we have 2 or more of the same functional group, so we have 2 methyl groups, we put the prefix di before the actual the methyl prefix, right? We also number it accordingly, so it's in the second and third position. So instead of writing 2-methyl-3-methyl decane, we just put 2,3 dimethyl decane. So far we've established a nice framework when it comes to naming organic compounds. So establishing the longest carbon chain, looking for functional groups, numbering them, and then naming them. I want you to keep that in a nice cupboard, right? In a separate cupboard comes naming esters and amines. So this kind of naming convention that we use so far kind of falls apart, or rather, we use a different naming convention when naming esters and amines, and I'll show you what I mean. So in our organic reaction video, you may recall, or you might be introduced to the fact that an ester is actually a link between an alcohol and a carboxylic acid. So I'm going to use 2 different colors here. So this is the alcohol, signified by the OH group, and this is my carboxylic acid, right? This gives me the ester linkage, and I've also got this group here left over from the alcohol, right? So thus, we need a naming convention that is representative of both the length of the carboxylic acid. So I could have a carboxylic acid of 7 carbons long, and I could have an alcohol of 3 carbons long. Or I could have a carboxylic acid of 2 carbons long, and I could have an alcohol of maybe like 10 carbons long, right? And if I combine them, they'll give me an ester. Thus, I need a naming convention that is reflective of the initial length of the carboxylic acid and the alcohol. And in the next slide, we're going to go over the name of this compound, and I'll show you why. So, like I mentioned in the previous slide, the constituents of the ester are both a bit of the carboxylic acid and a bit of the alcohol, and they create this ester linkage here. When you're naming it specifically, you need to find out which parts came from the alcohol and which parts came from the carboxylic acid. If we go back to the previous slide, it's a little more clear. So, in this slide, you can see that the carboxylic group and the alcohol group, both of their OHs react and they form this ester linkage here, and they give off a water. Again, this is covered in more detail, in our video on organic reactions, so I recommend you watch that to revise. But to name it, you do need to understand that an ester is made up of the carboxylic acid and the alcohol. So now how do you go about actually naming a compound like this? So what I like to do is I like to draw a line in the middle of the ester linkage. everything to this side came from the carboxylic acid. Everything on the other side came from the alcohol. And if we go back, that kind of makes sense. So everything on this side came from the carboxylic acid, and everything on the other side came from the alcohol, as you can see clearly demonstrated here. Thus, you count the number of carbons in the carboxylic acid, so 1, 2, 3, 4, 5, so this is 5, and the alcohol, 1, 2, 3, 4, 5, so this is 5. So this means it's a pent, this means it's a pent. Now to name this compound, the alcohol, you attach a YL at the front, and for the carboxylic acid, you add an O8, so O8TE, and that's how you name it. So essentially, work out the number of carbons contributed by the alcohol, and then find the prefix for that, add YL, work out the number of carbons contributed by the carboxylic acid, get the prefix for that, and then add O8. And I have another example at the bottom here, and we'll go through that. So again, the first thing we're going to do is break up this ester linkage. So everything on the side of the carbon double bond, so this side here, is the carboxylic acid. And everything on the other side is the alcohol. Now we need to count the number of carbons. So 1, 2, 3, meth, eth, pro. So that's pro, or prop, and the alcohol, meth, eth. So 2 carbons, so that's an eth. Once again, with the alcohol group, we add a YL, and that's the first part of the name. And with the carboxylic acid, we finish it off with an O8, and that's the second part of the name. So something pretty similar happens when you're naming amides. So in your mind, I want you to separate naming like your typical organic compounds from naming amides and esters, because you actually name them in a really similar fashion. So with an amide, it's actually made up of an amine and a carboxylic acid. So an ester is a carboxylic acid and an alcohol, and amide is an amine and a carboxylic acid, right? So something really similar happens. So you have your contributing amine and your contributing carboxylic acid. The amine group reacts with the OH to give you this amide linkage, and you also get water. So the OH kind of rips off one of the H's, takes a H2O out, and then if you can imagine, that's gone, and then one of the H's is gone to contribute towards the H2O, so you're left with the NH and the carboxylic acid linkage. Again, I'd recommend you watch our video on organic reactions. We go into it a little more deeper. But for this video, or just naming organic compounds in general, just have a good understanding of how it comes together, and you're going to be naming it in a really similar fashion to the esters, which we'll go through in the next slide. Now, with the naming of the amides, we do something really similar. So the first thing we're going to do is we're going to get our amide linkage, which is this thing here, and we're going to break it in half, right? So I'll break this in half. Everything to the side of the C double bond O is contributed by the carboxylic acid. Everything on the side of the nitrogen or the NH group is contributed by the amine, right? And now you're going to count the number of carbons on each side. So 1, 2, 3, 4, 5. So that's a pent. Carboxylic acid, 1, 2. So that's an eth, right? And you might be thinking, where am I getting these pent eth prefixes? All of those prefixes are in the previous slides when I was talking about the branched functional groups. That's where you want to get all those prefixes from. So carrying on, you kind of treat the amine like the alcohol when we're naming esters. So that gets the YL, and the carboxylic acid, instead of an O8, which we would add if this was an ester, we're going to add an anamide. So this is pentyl ethanamide, right? Same thing for the second compound. So breaking the amide linkage on one side, this is a amine. On the other side, this is a carboxylic acid. Now we're going to count the number of carbons contributed by each. So 1, 2, 3, 4. 4 gives you bute. On the amine side, we get 1, 2. So that's eth. We add a YL to the amine side. We add a anamide to the carboxylic acid side. Combine those and you get ethyl butanamide. This is a short summary slide with some of the rules for naming esters and amines. This is just another short summary slide on just naming organic compounds in general, aside from esters and amines.